While the exploration of the Martian surface has already revealed some breathtaking discoveries, the exact composition of the planet's interior has long been an unsolved mystery. Thanks to cutting-edge technology, NASA recently succeeded in getting one step closer to deciphering this galactic mystery. Equipped with a seismometer and a heat flow probe, the InSight lander has been investigating the deeper rock layers of the red planet for almost 3 years. InSight is not only intended to monitor the current composition of Mars but also to investigate the earliest development processes that gave the celestial body its characteristic shape. What information the InSight lander has already provided in this regard, and what questions still need to be answered in the future, we'll reveal to you now. Want to learn more about groundbreaking discoveries and great mysteries in the universe on a regular basis? Then don't forget to subscribe to Simply Space and never miss one of our videos in the future. If you enjoy the content of our posts, we would greatly appreciate a thumbs up. The InSight lander. In May 2014, NASA presented the public with its ambitious plans. At that time, the renowned space agency announced that it was working on building the InSight lander. This Mars mission was meant to answer several burning controversies that had divided experts into different camps for many years. The data transmitted by the technical equipment was not only expected to help fathom the nature of Mars but also to decipher the mysteries of all rocky planets in the solar system. This categorization of celestial bodies, to which our Earth also belongs, shares a common origin. Specifically, the origin of the planets is based on a process called accretion. During this process, a cosmic object collects matter by its gravity and the effects of tidal forces. As the terrestrial body grows in size, its interior begins to heat up. This process, in turn, is accompanied by a drastic reshaping, at the end of which a core, a mantle, and a crust are formed. The remaining rocky planets in our solar system, in contrast to the Earth, were reshaped later by a process called differentiation. This process, which describes the formation of different materials from a once homogeneous mass, is still one of the great mysteries of modern research. Experts hope that InSight's in-depth investigation of Mars will provide new clues about the earliest evolutionary processes of such celestial bodies. After the originally planned launch was postponed by more than 2 years due to a leak in the seismometer, the time finally came. On May 5, 2018, InSight left our blue home planet and set off for the fabled red planet. On November 26 of the same year, InSight touched down as planned on the surface of the celestial body, which is covered in iron oxide dust. To perform its work effectively, the lander was equipped with various measuring instruments. The so-called seismic experiment for interior structure is used to make precise seismic measurements on the red planet. By investigating such activities, important insights into the history of the planet can also be gained. The Heat Flow and Physical Properties Package instrument was designed to determine the heat flow in the Martian sediment. A 15-inch long and approximately 2-inch thick RAM probe was used for this purpose. In the run-up to the mission, the Warsaw-built device had the goal of penetrating about 16 feet into the Martian soil. The plan was for the RAM probe to stop about every 2.5 feet to carry out special heat measurements. This was to be done by calling up a preset heat output in each case. With the aid of the temperature sensors located on the head of the probe, the heating of the drill head and the rate at which the heat was spreading would then be measured. In the course of this procedure, the experts hoped to learn more about the physical properties of the Martian soil. However, the deployment of the equipment was not to be. In the spring of 2019, the RAM probe got stuck in the ground at a depth of about 1 foot. In fact, the friction between the heat flow probe and the Martian soil was much lower than the scientists had expected. After the RAM probe was freed by a robotic arm and able to resume its task, it was not long before the next problems arose. The instrument had once again become wedged in the ground. However, since this time it was not possible to free the RAM probe from its awkward position, the earthly scientists had no choice but to end the experiment at the beginning of 2021. The interior of the red planet. Thanks to the successful InSight mission, terrestrial scientists were privileged to record another galactic milestone. With its complex measuring instruments, the lander succeeded in registering more than 700 Marsquakes. With the help of the recorded data, researchers managed to make the first direct measurement of an alien planet's interior. Although more in-depth research is needed in the future to fully understand the tectonic makeup of the red planet, the information gathered so far provides important clues as to what lies beneath the red, rust-covered surface of Mars. On the one hand, the knowledge gathered in this regard helps us to better understand the current structure of the red planet. Additionally, this information can also be used to reconstruct how the celestial body was formed in the past. The seismological measurements carried out at the landing site of the InSight lander made it possible, for the first time, to constrain the thickness of the Martian crust in the corresponding region. Furthermore, by taking gravity and topography into account, it's even possible to map the crust thickness of the entire celestial body. Since experts have been waiting for several decades to unravel this cosmic mystery, the successful completion of this endeavor was tantamount to a galactic blockbuster. The data that InSight has so far transmitted to terrestrial scientists supports two different models. On the one hand, it's conceivable that the Martian crust is relatively thin and composed of two layers. The higher, porous layer may have been chemically altered over the millennia, according to researchers. While the investigation of the Martian surface has previously uncovered some stunning revelations, the specific creation of the planet's interior has long been a strange problem. Thanks to state-of-the-art innovation, NASA recently succeeded in taking one step closer to deciphering this cosmic mystery. Equipped with a seismometer and a heat flow probe, the InSight lander has been examining the deeper rock layers of the red planet for almost 3 years. InSight isn't just designed to monitor the current configuration of Mars but also to investigate the earliest developmental processes that gave the celestial body its characteristic shape. Exactly what data has the InSight lander already provided in this respect? What questions still need to be answered in the future? We'll uncover these mysteries now. If you want to stay informed about notable revelations and fantastic secrets of the universe on a regular basis, don't forget to subscribe to Essentially Space and never miss one of our videos. If you enjoy our content, we'd greatly appreciate your support. The InSight lander. In May 2014, NASA introduced its ambitious plans to the public. At that time, the renowned space agency announced it was working on building the InSight lander. This Mars mission aimed to address various pressing questions that had divided scientists for many years. The data transmitted by InSight's advanced instruments wasn't just intended to deepen our understanding of Mars but also to unravel the mysteries of all rocky planets in the solar system. This category of celestial bodies, which includes Earth, shares a common origin. Specifically, the formation of planets involves a process called accretion. During this process, a celestial object gathers matter via gravity and tidal forces. As the terrestrial body grows in size, its interior begins to heat up, leading to a dramatic reshaping process that ultimately forms a core, mantle, and crust. The remaining rocky planets in our solar system, unlike Earth, were reshaped later through a process called differentiation. This process, which describes the segregation of materials from an initially homogeneous mass, remains one of the great mysteries of modern research. Scientists hope that InSight's in-depth examination of Mars will provide new insights into the early developmental processes of such celestial bodies. After the initial planned launch was delayed by more than 2 years due to a leak in the seismometer, the opportunity finally arrived. On May 5, 2018, InSight left Earth and embarked on its mission to the legendary Red Planet. On November 26 of the same year, InSight successfully landed on the surface of the celestial body, which is covered in iron oxide dust. To perform its work efficiently, the lander was equipped with various measuring instruments. The Seismic Experiment for Interior Structure, SEIS, is used to make precise seismic measurements on Mars. By studying such activity, significant insights into the planet's history can also be obtained. The Heat Flow and Physical Properties Package, HP-3, instrument was designed to determine the heat flow in the Martian subsurface. A 15-inch long, 2-inch thick probe was used for this purpose. In preparation for the mission, the Warsaw-built device aimed to penetrate about 16 feet into the Martian soil. The plan was for the probe to stop at intervals of about 2 feet to conduct heat measurements. This was achieved by using temperature sensors on the probe's head to measure the heat diffusion rate. Challenges with the heat flow probe. However, deploying the instrument didn't go as planned. In early 2019, the probe got stuck at a depth of about 1 foot. The friction between the heat flow probe and the Martian soil was much lower than researchers anticipated. After freeing the probe with a robotic arm and resuming its task, further issues arose. The instrument got wedged in the ground again. This time, freeing the probe proved impossible, and researchers had no choice but to halt the experiment at the beginning of 2021. Significant insights from InSight. Despite these setbacks, the InSight mission has not been a failure. The seismometer has already provided critical data, offering unprecedented insight into the red planet's interior. Thanks to the successful mission, researchers have achieved a new cosmic milestone. With its advanced measuring instruments, the lander recorded over 700 Marsquakes. Using this data, scientists made the first direct measurement of the interior of an alien planet. Although more in-depth research is needed to fully understand Mars' structural composition, the gathered data provides crucial insights into what lies beneath the planet's rust-colored surface. It helps us better understand the current structure of Mars and reconstruct how the celestial body formed in the past. Seismological measurements taken at InSight's landing site allowed researchers to estimate the crust's thickness in that region. By factoring in gravity and geology, scientists can even map the crust's thickness across the entire planet. After waiting for years to unravel this cosmic mystery, the successful completion of this task was akin to a blockbuster achievement in space exploration. The data transmitted by InSight so far supports two distinct models. On one hand, it suggests that Mars' outer crust is relatively thin and consists of two layers. The upper porous layer may have undergone chemical alteration over centuries, according to experts.